Hi, welcome to Phil 111, which is Introduction to Inductive Logic. In general, the course is, even though it counts as a course in philosophy, it really counts for a math credit, so it's a very different kind of course from other philosophy courses. As a result, since it counts for the math requirement, there will be a fair amount of math in the course, but the difference is that we're emphasizing the concepts in the course. Since it's a part of philosophy, concepts are all important. So here's the procedure. What I'm going to do in this first lecture is go over in general what logic is about, and then describe to you some of the things you need to do to get through the course. It's not an easy course. That's just the nature of the topic, but I'll break it down for you about as nicely and as best as can be done. Keep that in mind for the rest of the course. The procedure is the same for all the lectures and the homeworks and whatnot. So you first read the book, follow the syllabus. That's part of the exercise in disciplining the self, exercising your mind, and so on and so forth. So follow the syllabus, learn to follow the directions, learn to keep on top of things. That's part of the exercise in self-discipline. So you first read the book. Even if you don't understand it, just give it a good faith pass. For those who don't have the book and think you can get away with it, I'm telling you straight up, you cannot. In fact, there are problems coming out of the book that are on the exams. And without the book, you simply can't do these problems. So you've got to have the book. You've got to use it as guidance, but you don't have to comprehend all of it. So after just trying the book and getting a sense for what it's saying, spend not a whole lot of time, just enough. You then come to my lectures that are located in the module section in La Lima. They are the key element to the course. They'll go over everything in detail. It streamlines the content that you need to know. And then from there, I have exercises, homeworks, and quizzes that you work and you turn in just to practice. This is the difference in a course in logic and math is the same. You got to keep up with the course. You got to do practice. It's unlike other courses where you think you can put it off and then you come back later. Absolutely not in this case. You've got to come to every class, do every homework. In this case, it's online. You've got to keep pace with the course and show up and do the work. Yeah, that's part of why this is a course, even though it's a course in that counts with the math requirement. It's part of a course in philosophy, which is really about self-cultivation. So keeping that pace, keeping that self-discipline, it's good exercise for you. Anyway, getting to the course itself, after you read the book and then you read the lectures, I also have videos to guide you through this. Usually I'll hit highlights. Sometimes I'll cover things in more detail, sometimes less. Sometimes I'll go on relevant tangents to indicate the number of applications of what we're going to find in this course is it's quite surprising. It ranges from things like medical practice to the elections and how Trump won, the manipulation of data, Google Analytics, big data, and all that. Your phones and the way in which you're being tracked. All that stuff comes in a sort of underlying way through this study of inductive logic. Its applications are so widespread in our modern day and age, but very often it's just not seen. So anyway, the videos will give you further guidance with the concepts. So let's start this first lecture by talking about what logic is about as a broad general map to situate our particular course. So logic, as the first bullet indicates, is the study of inferences, but that's a pretty broad kind of thing. I mean, inferences come in many forms. Sometimes they're conscious, sometimes they're unconscious. You can think of human beings, what distinguishes us from other creatures. It's sometimes said that we are logic secreting machines. What does that mean? Well, the idea is we just make inferences on a daily, minute by minute, hourly basis. We don't even realize it for the most part. You're driving on the road, you're just trying to survive, someone cuts you off, driving dangerously. Your natural reaction is, hey, what'd you, and then you swear, whatever, right? That reaction is a kind of inference. You think the person's being a jerk, and maybe they are. But what if the person just wasn't aware? Or what if the person was having a heart attack and they're swerving off the road? In which case, your judgment that they're a jerk is incorrect. The point is, we make inferences. That's the playing field of everyday life. But what we don't often do is reflect upon the inferences we make. We just don't have the tools for it very often. So you can think much of what logic is about, and philosophy more generally, is thinking about the process of thinking. It's sort of looking at the playing field, stepping back from the playing field of life, and then looking at our own minds and the ways in which the inferences occur. Okay, so keeping that in mind, there are two major types of inferences: what's called deductive inference and ampliative or non-deductive inference. This is not exhaustive; it doesn't capture everything, but we try to capture what we can. And these distinctions are very rough as well. Inferences are represented in philosophy by arguments, which are structures of reasoning separating premises from conclusion. By arguments, we don't mean two people yelling at one another. Very often in philosophy, and logic in particular, there are a lot of technical terms used, even everyday terms that are used in a technical sense. So it's very important to keep in mind that you've got to be aware of how the word is being used. So when we say argument in philosophy, we don't mean people yelling at one another. In fact, the very opposite. We very often mean a reasoned structure separating premises, which is starting information, from conclusion, what you're drawing out of that information. This vertical line is sometimes also called a Fitch bar. Deductive reasoning is what Phil 110 covers. Phil 110 is no longer offered at KCC. It's offered at some of the other colleges, Manoa in particular. It's deductive logic. It used to count for the math requirement. They stopped that. There is a series of logical inferences that are mistaken in that exclusion, but that's another argument. Here's a map for what logic is about. So logic splits into two sides: deductive, and then on the other side, non-deductive, or what's called ampliative. And then ampliative in turn cuts down to inductive and what's called abductive. We're focusing on this left corner here, inductive. But in order to get to that, we have to start the course with a bit of deductive reasoning. So we're going to spend the next couple of lectures, or next lecture and some of the upcoming work, talking about deductive logic, so that we can then explain how that relates to our course, inductive logic. Don't worry about all these terms, I'll just get to it below. So I'll just use examples to get at each of these types of inference. Okay, that's the best way to go. So here's a classic instance. Here's one argument. First two premises: all people are mortal. Socrates is a person. Given these two things, if someone tells you all people are mortal, Socrates is a person, suppose you don't know anything about people or mortality or Socrates. If they just told you this, would it have to follow that Socrates is mortal? The answer is yes, because of the structure or form of the argument. If all these things qualify as that, in this case people being mortal, and this particular name of what? This entity, Socrates, qualifies as this thing, it's a Socrates is a person, then since all those things are mortal, Socrates must therefore, since he qualifies, be mortal. So the idea is that a deductive argument just draws out what's already latent, what's already present in the premises. Yeah? So it's guaranteed, it's risk-free. There's no risk involved because you're forced to the conclusion. By contrast, a non-deductive or ampliative argument amplifies. It goes beyond what information is contained in the premises. That means it's inherently risky. There's some risk involved because you're not guaranteed of the conclusion. And that is the key division between deductive logic and our course, inductive logic. It involves risky inferences. Even if it's a small amount of risk, there's still some risk there. Okay. So for inductive arguments in particular, there's the premises indicate some kind of regularity, and then the conclusion generalizes from that. This doesn't actually include all inductive arguments, but for our introductory lecture, it's good enough for our purposes. Okay. So suppose you're a naturalist. You're back in the day, before they had much tech. You go around in boats, no airplanes. You've been around the world. You've seen 1 million swans. 1 million's a big deal back then. Now we think a million chump change, right? 1 million swans that I've kept records on have all been white. So now in this new continent, you're tired of doing this. You've been doing it for 10 plus years. You found that this population of swans is also white. So hence you're inferred to project that this large sample, to the total population. All swans are white. Now, in the past, in the future, all of them, which is a potential infinity, right? Strictly speaking, this goes beyond what we're entitled to infer from the premises, because our premises only have samples from these various regions. It looks plausible that all swans are white, but we don't know that for sure. And in fact, there's a counterexample. In Australia, say this naturalist missed that one continent, right? That one area. In Australia, you have black swans. There's also, I should mention, a book entitled, or it's basically about this notion of black swans. Things that for all purposes, inductively speaking, things look regular, things look like you can project them, and yet things fall apart. And one of the best working examples of this is our economy. We think it works fine. We think it's projected. We got confidence. We're going to make America great again. Blah blah blah. And all of a sudden, boom, the thing just goes bust. And all the economists are surprised and befuddled, except for a few economists, mathematicians, and logicians who said, no, that's an inductive mistake. There are what are called systemic black swans in the economy that can blow up the very thing, resulting in, for example, the 2008 crash, which the wreckage of which we're still living with today, whether we realize it or not. It's there in our daily lives. You notice things falling apart all around you. Very often people don't connect this up. Much of mainstream media misses this as well. I'm not talking about Trump's fake media, which is about as fake gets. I mean, we're talking about real media, CNN, Fox News, and whatnot, and how they, even so-called respectable media, New York Times and whatnot, they miss much of what's going on. So they don't see the black swans, but those who are critical thinkers and look at things from this perspective of inductive logic have come to realize that black swans are a major issue. So even if we have regularities, there may be huge systemic risk in the inferences we make, leading to things that are not so regular, like the crash of 2008. Okay, that was a bit of a tangent, but the point is, a lot of the tangents I go on will help to sort of indicate the more widespread application of these rather abstract concepts. They don't seem to have application, but what I'm trying to say is it's already applied and we're immersed in it. Very often we don't even realize it. For the next type, abductive argument, which is the other type of ampliative inference, the fancy name is abduction. The informal name is inference to the best explanation. So here's a homely example. You're in class, you walk outside, pavements are wet. This being Hawaii, you feel that the air is muggy. The natural inference to that is, oh, it must have been raining. And that's a good explanation. It's probably the best explanation, but it's not guaranteed. Why? It may just be a muggy day and it happened that there was a water main break, but it never rained. Okay, so the above map gives you, in essence, what logic is about. What we're focusing on, again, in our class is inductive logic. But to do that, we first have to spend some time on the deductive side. And on the deductive side, the key idea is that of validity. The definition of validity, not I like, remember, you have to distinguish technical uses from informal uses. The informal notion of valid is just someone saying, oh yeah, that's a valid point, I like it, I agree. But that is not exactly not what is meant by validity in deductive logic. Here's the definition. If the premises are true, assuming the premises are true, the conclusion must be true. You're forced to it. That's what makes valid arguments risk-free. Why? They're guaranteed. If the premises are true, you're guaranteed. You have no choice. You are forced to the conclusion. Going back to our example above, right? If it's true that all people are mortal and Socrates is a person, assuming that, are you forced to the conclusion Socrates is mortal? Yes, you have no choice. It's guaranteed on the assumption that your premises are true. Not that they're actually true, but on the assumption that they're true. So there's an example of a deductive argument, a valid argument, and what makes for validity is applying this definition. Building on top of validity is something called soundness. An argument is sound when not only is the argument valid, but also with increased strength. The premises are in fact true. So you don't have some rubbish premises, but premises that are true, in which case the conclusion, you got no choice, it's true as well. Not hypothetically, but for real. Okay? That's enough for today, for this lecture. So be sure to just follow the syllabus and sequence, stay on top of things, read the book first, read the lectures, just keep the pace. That's the key to the course. You do that, and everything should take care of itself. But do not take it for granted. You've got to keep up the work. It's an exercise in self-discipline that is very much a part of what logic is about and why, once again, it's part of philosophy, which is in many ways exploring the human experience. Okay, see you folks next time.